Today I'm going to explain you how the first experiment code works. First one is to find the sum of prime numbers till the nth value. So here first I made a function and I passed n as an argument to the function. So after that I made a list which has elements from 0 to n plus 1, and I'm assigning all the value of the element as true, a boolean value. Then I make a variable called a and assign it to 2. So the concept here is the square of an element should always be less than or equal to n. So in prime numbers from 0 to n, all this except like the base case, other than them all their squares will be non-prime. So the square of the number, like from there, so like until this condition is like true, this whole loop will run. So until like first one is a square, a is equal to 2, so until 4 is less than equal to n, first loop will run. Okay, so then here, so if ARR of a, that is we pass the value of a as an index to ARR and find if it's true or not. If it is true, this if loop will be executed. So in this if loop we have a for loop where this for loop ranges from a square to n plus 1 in steps of a. That is, for example, if I have 2, like first one is 2, so 2 square is 4. 4 to, for example, n is 10, so it'll be 4 to 11 in steps of 2, so it'll be 4, 6, 8 and 10. So all this will be taken as I values. So and like we're passing this I as an index to ARR and assigning that value as false. Okay. So after this process, then we are incrementing the value until this until this condition is satisfied. This loop will run and assign all the remaining variable as false. Now we actually have a variable called su, which is whose purpose is to be like to store the sum of the values. Okay, so here what I'm doing is I'm having a for loop from 2 to n plus 1, and if in that range, if in the list from 2 to n plus 1, if it's true, then I'm adding that index to sum. So if you see, like if 2 is true, like if AR of 2 is true, then sum will be plus equal to I, that is sum is equal to sum plus 2. So after this whole for loop runs, it'll have the total sum. After that we just need to print the sum. So this is the working of the function. Now we're calling the function here and I'm passing like an value, like I'm using input function to get a value from the user, and I'm converting it to integer and passing it as an argument inside this function sum of primes. This is the first problem. So next problem is to find the nth Fibonacci number. So here I've used a concept called recursion. So you can implement this same Fibonacci using hash tables, using DP with memoization, but then I just use a small topic called like small easier one called recursion, but the time complexity for this is high. But then for this example I just use recursion to be like short and sweet and easily understandable. So here in this, okay, recursion is when a function calls itself like when when a function calls itself, then we call it as a recursion. See here, so here we have a base case for all recursive functions. We should have a base case, or else the function will be calling itself infinite times. So here we have a base case, that is when n is equal to 1 or less than 1. Like if it takes value as 0 or 1, we return n, else we return like Fibonacci of n minus 1, that is calling this function like this number minus 1 plus Fibonacci of n minus 2. We add this. So here we have two recursive calls. So as long as this Fibonacci of n becomes 1, there will be loads of recursive calls. When it's equal to 1, then the value will be written as 1. Then it'll go from bottom up. So that's how it works. So here we get the input from the user, convert it to int, assign it to a variable called n. Then we print, call the function and have the parameter of n. So the value returned will be printed. So next thing we are going to see is Armstrong number. So the sole purpose of this problem was to see if a number is Armstrong. If it's not an Armstrong, then see if it's odd or even. So if as you can see, I made a function called Armstrong and passed a variable like integer as a parameter. So first one is I make this integer as a string so that I could take digits from each places, like from tens place, hundreds place, thousands place, without making it complicated. So in Python we can use strings, like we can convert integer values as strings, and then we could do this. But normally if we can't do this, we use a modulus function and the division function to get digits from individual places. So an Armstrong number is a number where the sum of the cubes of digits in each place will be equal to the number. For example, 3, 2, 3. So 3 cube plus 2 cube plus 3 cube, if it's equal to 323, then it's called Armstrong number. So for that, what I did was I made as a string, took individual values and added like the cube to sum. So if the sum is equal to the number, then we return true, else we return false. Here I get an input from the user, convert it to int and assign it to a variable n. So if Armstrong of the number, this number, if it's true, then this if condition satisfied. If it returns true, it'll get satisfied and print Armstrong number. Else if it will do modulus operation and by 2, mod 2. So if mod 2 will be equal to 0, then we know it's even. If it's not, then it's odd. So that's how this program works. So next thing is sum of odd numbers within the given range, sum of even numbers within the given range. So first we get an input from the user, convert it to int and assign it to variable n. Then we have variable su for sum. Then we iterate the range 1 to n plus 1 in steps of 2. So what this will do is, it'll start from 1, then 2 steps, that is next 7 will be 3, then 5, then 7 until n. It will go until n. The last element n plus 1 will be omitted. So I'll add all the sum, then we'll print the sum. Then again we assign it the variable sum to 0. Then we again use a for loop. This time it's from 2 to n plus 1 in steps of 2. So here it will be from 2, then it will go to 4 up to n. So 2, 4, 6, 8, then go to n, like that. Then it will add all the values as sum, then it will print sum of even. And now the last program. Last program is to calculate the sum of squares within the range, sum of cubes within the range. So as usual, we're having an input from the user and then converting it to int, assigning it to a variable called n. Then what we do is we have a variable su for sum. Then we iterate through 1 to n plus 1 in the elements in the range 1 to n plus 1 and add the square of that number to the variable sum. When we print sum of squares, that's sum. Then again we assign sum to 0 again we do this same for loop here, but then here the only difference is here it's I square, it's I cube here. If you can see, it's I times I times I, it's I cube. We add that to the sum, then we print it. So that's it, the explanation part. So now I'll show you the output for each program. So the first program, I'm going to give the value 10 for sum of prime. Okay, I'm giving the value 10. So the expected answer should be 17, I guess, if I'm right. Uh, just a minute. Okay, so the answer is 17, as I told you. Next to be Fibonacci. So the 11th Fibonacci number, we'll see what's the 11th Fibonacci number. It's 89, that's right. Then we have Armstrong number. So for this case, I'm gonna input an Armstrong number to see if it's outputting it as an Armstrong number. If it outputs, then we know our program works. So 407 is an Armstrong number. I'm inputting that. So as you can see, it's printing Armstrong number. So then we will go to sum of odd and sum of even. So I'm gonna give a value 9. So what we're gonna do is we're gonna find the sum of all odd numbers from 1 to 9 and sum of all even numbers from 1 to 9. So sum of all numbers from 1 to 9 is 25, even is 20. Last program is to find sum of squares and sum of cubes. So I'm gonna give a value of 5. So it's going to find the sum of all squares, that's 1 square, 2 square, 3 square, 4 square, up to 5. Same thing will be done for cube. So if I give this, it's showing me 55 and 225, that's the right answer. Now as you can see, all the program worked, and thank you for watching.